and the distances of those construction lines. So hopefully if you didn't follow along completely, you can check that image. All right. So we've done the hex, we've done the snail. Let's now do the heart. The heart is a new one for me. I haven't done that one before. It's kind of interesting. So this dimension drawing really doesn't adequately explain how to make it. So I've got some screen captures during making it that I'm going to try to capture again this period, and I'll put those into the document. But let's just go ahead and do it, and you'll see what happens here. So I'm going to go to my cam template, right click, duplicate, come over and immediately rename that to heart. And confirm I have my configuration variables. There they are in the upper left, so I think I'm in good shape. All right, to make this one, again, I'm working on a better sketch to dimension drawing, but for now, I think the video is going to be key. So what we're going to do is we're going to, where's that? Like this is the, this is a picture of the heart. And what we're going to do, you can see there's a center point here and here and here. We're going to make a circle here, a circle here, a circle here, do one of those lines like we did with the pear. Then we're going to make a circle up here, as you'll see. So let's go ahead and get started. So the first time I'm going to make a circle here in the upper right quadrant, quadrant 1, of diameter d over 2, nominal diameter over 2. That's located d over 8 from the x-axis and d over 5 from the y-axis. Okay? So d over 2. Let's start that. So this diameter is nominal diameter over 2. They tell me that this distance here to here is nominal diameter over 8. And this distance from here to here is nominal diameter over 5. Okay? All right. Now, you can see there's another one right here. And so what we can do is we can use the mirror tool up here in the center. If I click mirror, and then click the y-axis, and then click my sketch component, it'll flip it over that y-axis. So that helps us out a little bit. Okay? The next one is a circle that's down immediately below the origin on the y-axis, and it's got a diameter of d over 5, nominal diameter over 5. So n divided by 5. Okay. Now let's go ahead and okay, we need to locate it. So this is, be careful here, you got to zoom up so you make sure you get the origin. So click on the origin and then the center of the circle. And this one, interestingly, is 9 times nominal diameter divided by 20. Okay. All right. Let's put in 9 times the nominal diameter over 20. That's right. It's in figure 2 on the assignment document. But yeah, it's kind of a funky number, but we'll take it. So I'm going to do the trick with the lines and make them tangent, and then trim them. And I think I'll just trim them in real time here. And I'll do the same thing on the other side. Tangent constraint, line to circle, and then line to circle. And I'll trim away that part and that part. Okay. All right, we're getting very close. So the final circle I need to make is, because I don't want to have this little sharp area right here, I want to make that smoother. So,
don't you need that second circle on the left one?
which circle?
The left one.
I did a mirror. Where you click the mirror command and then the y-axis and then the circle. Did it work? Okay, we'll circle back and talk about that, but the next thing I want to do is make a circle, final circle, that is directly above the origin, and its diameter is nominal diameter over 5. Now, the way we locate it, instead of through numerical values, we're going to use a tangent constraint again. So I'm going to click here, in this circle, and then this circle, and it drops it down in there and fully constrains it. So what I want to do, so that I can better document how to make this in case you're going to be working on this later, is I want to put in some what's called driven dimensions. So like the distance of that one, whoops, from the origin, in case you're doing this on your own. You can see it's gray because it's not changing anything. It's already fully constrained, so if I start to dimension on a fully constrained sketch, it'll just document dimensions rather than force the system to be at that dimension. Okay, so here we go.
Hey, how do you get the circles that you can see?
For this circle up here, I did a tangent constraint with either of these circles here. Okay. All right. Now I'm going to grab this sketch and I'm going to put it into the assignment document so that if you're working later, you can use that. Maybe it'll fit right here. Make it a little smaller. Okay. So this would be like figure 3, sketch for art cam. Okay. So hopefully can be useful later if you're doing this. All right, we'll come back here, and now we can start to trim. So we'll trim the insides, of course, there, 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 and we will trim there, there, and finally out here, there. And of course it looks like a heart now. So, yeah. So now we just need to put in the axle. This is just axle dia. Enter. And we can finish the sketch. Extrude a distance THK. Accept that. We'll make this, give it an appearance of, we'll make it red since it's a heart. We'll assign ABS. Oops. ABS. Plastic. And finally we'll come over here to the part and we'll rename it heart. And just for comparison purposes, go to mass properties display. So we got a volume of 856.856. So let's see. Hopefully I got that. Yeah, 0.856. So that information is in the document. So, yep, that's in the cams folder, so that was good.